Three, two, one, zero. Ignition. Liftoff.
So many of you have been looking up to space rockets getting into launch and thought, how does that thing even fight against Earth's gravitational force and make it to the space? You know, I mean, just basically a metal skyscraper shooting into the sky. So today we'll be exploring how rockets actually escape Earth, what kind of power it takes, and what obstacle would they face, during the process, and what make space flight even possible. So buckle up. This is a rocket science, but I will try to explain that in a way you can actually understand them better. So let's get to it. Earth gravity is no joke. It is an invisible force pulling everything toward the ground, and to escape it, a rocket really need to move very fast. Like, how fast, you might ask? I would say around 11.2 kilometer per second. That's about 40,000 kilometer per hour, and it is a speed known as escape velocity. At this speed, you can leave Earth pulling without falling backward. But here's the twist: rockets don't hit that speed instantly. Instead of jumping into the space, they accelerate over time through multiple stages. It's just like climbing a giant invisible mountain that is actually made of gravity. So, at the heart of every rocket is one thing: the thrust. Rocket engines burn fuel and oxidize to create a super powerful explosion that pushes downward, which in turn pushes the rocket upward. We can actually thank Newton third law for that, which says for every action there's an equal and opposite reaction. Unlike a car or jet, rocket doesn't need air because space has none. And if you actually understand space, you understand space has no air in it. Like, there's no any visible air, like you can't see anything in it. That's it. So that's why rockets carry their own oxygen in the form of liquid oxidizers. Now, here's a clever trick. Instead of carrying one giant tank of fuel all the way to the space, rocket uses multiple stages. Each stage has its own engines and fuel, and once it's empty, it is dropped off actually. This reduces weight, allowing the rocket to accelerate faster and higher. Think of it as dropping off a backpack during a hike to actually move, very quicker and faster. Most rockets you see, like the SpaceX Falcon 9 or the NASA Artemis rocket, use two or more stages to reach orbit or beyond. Depends on where you are actually going. While gravity pulls you down, the atmosphere resists your motion. As a rocket rises, it faces air resistance, which is strongest near the ground. So engineers actually think that, okay, how can we actually minimize this? So they came up with an idea. To minimize this, rockets are designed to be aerodynamic with a narrow tip and smooth shapes. Also, most of the speed builds up happening once the rocket is already high up, when the air is actually thinner and the drag is lower. So actually, not all rockets need to escape Earth completely. Some just go into orbit, like satellite and the International Space Station. So to do that, they need to go sideways really fast, not straight up. So that speed is around 7.8 kilometers per second. That actually let them fall around the Earth rather than just back down to it. If your goal is to go to the moon or the Mars or into deep space, you will need that full 11.2 kilometers per second to escape velocity plus extra for your destination actually. The legendary Saturn V rocket that took Apollo astronauts to the moon stood around 363 feet tall and used over 2.8 million kilograms of fuel in just its first stage. So, modern rockets like the Falcon 9 are usable and efficient, but still rely on the basic principle, just to burn fuel very fast enough to overcome gravity and drag. But the new Artemis 1 rocket, it's one of the most powerful engines that actually designed. So it's actually designed to send humans back to the moon.
2, 1. Lift off.
So once a rocket escapes the atmosphere and hits the required velocity, it actually goes to the space. It's actually free from air, it is free from drag, and mostly gravitational force that's actually pulling it. So from there, it can actually maneuver with tiny thrusters, adjusting orbit or head to another planet actually. But getting to that point, there's a massive battle against Earth itself. At every launch is a masterpiece of engineering, timing, and precision actually. So next time you see a rocket blast off, just remember, it's not just rising, it is fighting against gravity, air, and physics to reach its stars. So if you actually find this helpful, hit the share and share it with someone that actually loves space, and subscribe for more cool content like this. So see you in the next launch.